Hello guys, in this video we are going to discuss the solution of the problem find length of loop. So let us look at the problem statement. The problem statement says given the head of a linked list, determine whether the list contains a loop. If a loop is present, return the number of nodes in the loop, otherwise return 0. So for instance, if we look into this linked list, it contains a loop and the length of the loop is 1, 2, 3 and 4 and that is what we need to return. So that's about the problem statement, folks. Now let us discuss the solution of this problem. So the general idea behind solving this problem is, first we need to detect loop, and once we detect loop, we need to return a node of a loop. And let us say if there exists a loop, then we will find the length of the loop and we are going to return it. So let us take a look how are we able to detect loop in a linked list. So for that, let us take an example. So let us say this is the linked list and a loop, as you can see, exists in this linked list, and this is the head of the linked list which is given to us. Now what we are going to do is we are going to take two pointers. One is a slow pointer. So let us say this is my slow pointer, and another is the fast pointer which will be at this position. Now what we are going to do is we are going to iterate on the linked list while fast is not equals to none or fast is not equals to slow. So let me write it down. While slow is not equals to fast and fast exists and fast next also exists. And within this loop, we are going to update our slow pointer by slow equals to slow of next, and fast pointer we are going to update it twice. So fast will be equals to fast dot next dot next. And in this way, if we run this, so let us run using this logic. So for the next iteration, my slow will be here. So this will be my slow. And our fast will be, since the fast has to be updated twice, so fast will be equals to fast of next of next. So the fast will come over here. In the next iteration, slow will reach to this position. So this will be our slow, and fast will be equals to fast of next of next. So fast will reach over here. And at this point, we realize that slow is equals to fast. Once we realize that slow is equals to fast, that simply means that there is a cycle. If there isn't exist a cycle, then slow will never be equals to fast. So in this way, we will be able to detect whether there exists a cycle in the linked list or not. And once we have detected that there exists a cycle, so towards the end, all we have to do is we have to check whether slow equals to fast. If slow equals to fast, then that simply means there exists a cycle in the linked list and we can return slow, which is a pointer in the loop. Otherwise, we just have to return none, indicating that there isn't exist any cycle in the linked list. Now once we have this pointer with us, it becomes easy to count the number of nodes in a cycle. So let us count the number of nodes in a cycle. So for that, all we have to do is, so let's say we want to count loop length, and to this we are going to pass head, and this head is not the head of the linked list, rather this node, which is a node in a cycle. Now once we have this, all we have to do is let's have a length, initial value of length equals to 1. Let's have a PTR whose value is equals to head dot next, and then we are going to iterate on PTR while PTR is not equals to head. Please note, if we are in this loop, we are sure that there exists a cycle, so that is why this condition is a safe condition. Then all we have to do is we need to increase our length by 1 and we need to update PTR to the next pointer. So PTR will be equals to PTR of next. And then towards the end, we just have to return length. And in this way, we will be able to find the length of the loop. So that's the discussion of solution, folks. Now let us see how we have implemented this in Python and C++. So first, let us look at the Python implementation. So the first thing which we are doing is we are detecting a cycle in the linked list. And to detect the cycle in the linked list, we have our PTR pointer. And let's say if the linked list is an empty linked list, then we are returning head, which is simply a none, indicating that there doesn't exist a cycle. Otherwise, PTR equals to head, which is our slow pointer, and then head equals to head of next. This is our fast pointer. And then we are checking whether head and head dot next equals to PTR. It might be possible that exists a loop of length 1. That is what we are checking it over here. In that case, we are returning head. If head and head dot next exists, then head equals to head of next. And then the case where we are trying to detect the cycle. If there exists a cycle, then PTR will be equals to head, in which case we can return PTR. Otherwise, we are going to return none. And in this way, we will be able to detect cycle in the linked list. Then, if there exists a cycle in the linked list, then we are counting the number of nodes that exist in that cycle. And to do so, length equals to 1, PTR equals to head, PTR equals to PTR of next, and we are iterating on the linked list, or rather the cycle, while PTR is not equals to head. And then we are updating our length and PTR pointer, and towards the end we are returning length. So that's the Python implementation, folks. Now let us submit our solution. So our Python solution got accepted. Now let us look at the C++ solution. So the C++ solution is also the same, folks. Again, a detect cycle, and the logic remains the same, folks. So I'm not going to go over it again. And similarly, we are counting loop length, and towards the end we are returning length. So that's the C++ implementation, folks. Now let us submit our solution. So our C++ solution also got accepted, folks. That is all from this video. In case if you have any question or comment regarding this video, please feel free to use the comment section and I'll try to address them. Thank you.